Hello everyone, today we're going to go over the 40s and 40.1 is your homework.
So today's going to be all about naming compounds. So we're going to have our formulas and we're going to go through some different naming cases. In total, we'll go over five different naming cases, but today we're just going to go through case A and case B. So please have your periodic table out as we're working today. You'll also need obviously the 40s worksheet. It'll be a pretty quick video. We'll go through a couple examples and then you'll have some homework for tomorrow. All part of the plan.
Today we're going to pay attention to the charges in the boxes as we're going along. And over here, your periodic table does in fact have charges in the box. On our old periodic table, we have the charges up above. All right, so page 40 says the first element is a metal with only one charge. What do we mean by that? We simply mean there's only one charge in the box. So we're not talking about these elements now. We're just talking about single charges in the box. It could be a 3, it could be a 2, it could be a 1, it could be a 4. We're not talking about the ones that have multiple charges in the box right now. And then the second element is any nonmetal. The instructions, write the name of the metal, but don't include a parentheses, and then write the name of the nonmetal with an "ide" ending. So the first one was done for you. We wrote out magnesium, and then instead of oxygen, we called that oxide, and that's where we get our name. Potassium is done the exact same way. We write out the name for potassium, and then we write out not sulfur, but sulfide. The reason we're going through this kind of fast is because we already did this case on the last homework assignment. So now let's go down to rubidium and selenium. So rubidium, we write out its first name, rubidium, and then selenium turns to selenide. Chop off the last part of the name and add an IDE ending. Mr. Borowski, you want to do the next one?
Sure. So here's our formula right here. We have Ba3P2. Ba is barium and P is phosphorus. But again, when you're naming these case A compounds, all we need to do is name the first element as it is. And then for the second element, we chop off the end of that and replace it with ide. So this turns into barium phosphide. Okay.
Hey, Barazin, before we move on, do you know what you do with an old chemist?
Well, you bury them.
You bury them.
Isn't it like what do you do with a sick chemist?
Yeah. Old sick chemist.
So if you can't helium,
you bury them.
Well, if you can't curium either.
Oh.
If you can't helium and you can't curium.
Oh, you can't helium and you can't curium, you bury them. Gotcha. All right.
All right. So for our next case, all right, and I'll come back to that periodic table. Let me reference what we're up to first, then I'll hop back and show you what I'm talking about. So for case B, okay, the first element is a metal with more than one charge. So opposite of what we just did in case A, now we're looking at all of these, right? All of these element boxes on your periodic table that have more than one charge or have an option, right? It could be a +2, +3, +4, +7 if you're looking at manganese, for example, all right? So we're ignoring the single charge metals, the single charge positive ions, and we're looking at the multiple charge positive ions now. All right, so first things first, the second element is still just any nonmetal. All right, so any nonmetal. All right, so step one, write the name of the metal and include parentheses for future placement of a Roman numeral. So Roman numerals look like this. You might be familiar with them. All right, we have a spot on your periodic table that goes through them. And I'll scroll down, I think. Right here. If you flip to the back of your periodic table, all right, there's a little box right in the middle on the back side of that. And up top, we have all the Roman numerals 1 through 10. All right, we'll never use up past 7, I don't think. 7's the highest we get. But you should be familiar with those. And if you're not, you have that resource. You can always go back and find it.
In every quiz and every test, you get to use your periodic table on, so you don't have to memorize the Roman numerals, but you will start to learn them as we're going along.
Okay, so first things first, we wrote that metal, we leave parentheses. Awesome. Second thing, we write the name of the nonmetal with an IDE ending, just like it was for case A. Step 3, mathematically determine the charge of the metal from the charge of the nonmetal. Yeah, we have to do a smidge of math to make sure we get the correct Roman numeral. And then write the positive charge of the metal as a Roman numeral inside the parentheses. And again, Roman numerals 1 through 7 look like such. So we have to figure out what the Roman numeral actually is. The Roman numeral represents the positive charge, okay? So just as an example, before we get too much further, if I were to have titanium with a 2+ charge, okay, the Roman numeral I would use is 2. If I have chromium with a 6+ charge, the Roman numeral I use in the parentheses is Roman numeral 6. All right, so let's keep going. So I have an example here. We have iron bromide, okay, and we find that iron, or Fe is iron. Iron has more than one possible charge. When I say that, what we mean is in that little element box on your periodic table, there's an option, right? It's either a 2+ or a 3+. We don't know which just yet. So we write iron to start our name. We leave open parentheses. Next, we find that Br has the name bromine, and we change it to bromide. So we're left with, at that point, iron blank parentheses bromide. Since bromine is in the halogen family, bromide has a charge of 1-. Okay, that should be right in the element box for you guys. We have it above here, but in yours it should be in that box. And then we look at the subscript on bromine and see that it's a 3. So there's 3 of them, right? So if each bromine has a 1- charge, the total negative charge from those bromines or bromides is 3-. When we make compounds, we want to make our compounds neutral, meaning neither positively or negatively charged. They balance out perfectly, right? So we have 3 -1s. In order to counteract that, we must have 3 positive from the iron. Okay? So there's only one iron atom. Oops, I just kind of crossed that out. Let's try that again. There's only one iron atom in our formula, right? Here was our formula right there. So if we need 3 positive, the full 3 positive charge must come from that one iron. So in other words, our iron is 3 positive, and we're going to use iron 3, Roman numeral 3 in our name. So when this is all said and done, do we have it written on here somewhere?
I don't believe so.
I don't believe so either. It's going to be iron 3 bromide. There we go. Bromide. Okay.
If that seems confusing, you'll understand it more as we go through more examples.
I'm falling too.
All right, so here we go. We have iron and we have bromine. So the first thing I would do is I'd go and find Fe. I find Fe right here. I find Br over here. Apologize for that. It doesn't seem to be showing up for us. And I see I have multiple charges in the box. So what I do is I go up here, I write iron. I leave a parentheses because I got to figure out, is it the 2 positive or the 3 positive? I change bromine to bromide. And now I have to do a little bit of math. So each Br, if you look in the box for bromine, bromide, the charge in the box is a 1-. But there's 3 of them. So that's a 3- overall charge for all of the Brs added together. So what must the charge of this Fe be for the whole thing to add up to 0? So what plus 3- equals 0? That's what I'm talking about. So that would have to be a 3 positive. So if I go back down to Fe and I look in there, there is in fact a 3 positive charge. That reinforces that my answer is correct. If I don't get one of the charges that are in the box, I might have done something wrong. So this would be iron 3. And if I don't remember the Roman numeral, for 3, I look on the back side of my periodic table. Right now, I'd like you to pause the video and you try this one. All right, assuming that you pause the video, I'll go ahead and I'll do this next one. Again, on the periodic table, Fe has multiple charges to pick from. I don't know which one I have to use yet. So I call it iron. I'll leave a parentheses because it has multiple charges. I'm not sure which one I need to use. We already learned that bromine turns into bromide. The charges on bromide are 1-. but I have two of them, so the total charge on the BRs is a 2 negative overall charge. So now I got to figure out the charge on this Fe. I only have one Fe, so whatever I put in here plus 2 negative has to add up to 0. So that would be a 2 positive. So it'd be iron 2 bromide. If we don't add up to 0, that would mean this compound has a charge, and that would make it reactive. Could be positive, could be negative, and it would want to react with other elements off the periodic table to make yet another compound. All right, pause the video. Go ahead and try that one. Mr. Brosnan will come up and teach that one in a second.
All right, assuming you are back, we have CuO. Cu is the element copper right here. And if we look inside copper's element box on your periodic table, we've got multiple charges. So we're going to start with writing out copper and leaving those blank parentheses to work with. O is oxygen, but we can't call it oxygen when we have it in a compound like this. It's not on my periodic table. That's okay. So we're going to call it oxide, right? We need to switch the ending. Now, if you are looking at your periodic table and you find oxygen, we'll look it up and we'll see that it has a 2 negative charge, okay? And I'm going to write that a little further away just for the sake of making sure we don't confuse that it's not a part of that molecule. This is 2 minus. There's only one of them, so total is 2 minus. I only have one copper. So again, in order to make this molecule or this compound neutral, I need to have the positive charge of this kind of cancel out the negative charge of that. So what is this if the end goal is to have the molecule be neutral or 0 in charge? Okay, this is pretty simple. That's got to be 2 plus, right? I put a Roman numeral 2 in my parentheses to finish the name. And again, for one final check, if I go down and look in the element box, hey, that is an option. So I must have done this correctly, or most likely I've done this correctly. Pause it again.
No, I do the one right below. Have him do the one below.
Oh, okay, fine. Don't pause it. Or if you did, welcome back. Nothing's happened. Try this one, okay? It is also copper oxide, but again, the ratio is different. So now the math changes just a little bit. Pause it. Come on back. All right. So we are starting with the same 2 elements. I'm going to set up the exact same way. My math's just going to change. That's all that's going to happen here. So I still have Cu. That's still copper. Nothing has changed. We do have options for the charges. So I'm going to start with this copper, blank parentheses. Oxygen is still my second element. I switch the ending of that name to oxide. And now I consider the math. I consider the charges that I have. Oxygen is still 2 minus. I only have one of them. Okay. But now I have 2 coppers. So the end goal is still to eventually have this molecule be neutral, right? We want the negative charges and the positive charges to cancel. But now I have a total of 2 positive that I need. But the problem is that I have 2 coppers. So individually, each of those coppers must be 1 plus. This is a little more confusing. And I could set this up like algebra if I want to. Some kids will like that. Some kids won't. At the end of the day, right, we know that this must be 2 plus. It has to be 2 plus. But each copper, since I do have 2 coppers, each copper must be 1 plus. So really, it kind of turns into this thing, right, where I have 1 plus 1 to get, then the negative 2 to get to 0. There's different ways to show that. There's different ways to do that. Mr. Scheidler might do that a different way than I just did it. But you've got to be aware that if we have more than one of these things, more than one of those coppers, that positive charge gets split between the total. So this ends up being a Roman numeral 1, because don't forget that your Roman numeral is the charge of the metal, not how many there are, right? This is a Roman numeral 1 because these are 1 positive coppers in that molecule. All right, try the bottom left one if you could. Pause it. Go there. Scheidler will be back in just a second to help you out.
All right. if you're not pausing the video, you are going to have more problems than the average student. So you do need to practice these, stress your brain out a little bit, and then that way you'll be better able to learn what's going on. So V is actually element 23. It's vanadium right here. I can see there's a whole slew of charges in the box. So I write out vanadium. It's got multiple charges. I put my parentheses. Nitrogen turns into nitride. And now I do some math. So if I look at nitrogen, which is over here, you should have a 3 negative in the box. I have it up on the top of my periodic table. So each nitrogen is a 3 negative, but there's 5 of them. So 5 of those 3 negatives would be 15 negative overall. So what plus 15 negative equals 0? Well, that's got to be 15 positive. But I have 3 of these vanadiums. So how I look at it is I take this 15, I divide it by 3, and I get the value of each of the vanadiums. And that would be a 5. And if I don't know the Roman numerals, I look on the back of my periodic table and I find them. So if each vanadium has a 5 positive charge, that would give me this 15 positive, which will balance it out and give us a 0 overall. So last chance for you to try it on your own. Do the next one and see if you can figure it out. Make sure you pause the video. All right, assuming you pause the video. So again, I have vanadium. It's got multiple charges. I'll leave a parentheses. Nitrogen turns into nitride. And now I have to do the math. So again, nitrogen has a 3 negative charge, but there's 4 of them. So that's a 12 negative. This whole thing has to add up to 0. So what plus 12 negative adds up to 0? That would be 12 positive. But there's 3 of them. So I take this 12 positive, I divide it by 3, and I get the value of each of the vanadiums. And that would be a 4. Again, that's Roman numeral 4. It's on the back of your periodic table. I go down and I check. And yes, vanadium does have a 4 positive charge. One thing that students do get confused on, they start not really understanding what's going on. They'll think that this right here is telling us how many there are. And if you do that, you're going to end up getting a lot wrong on your assignments. So that is the teaching for today. You have the next side to do as homework. And remember, you can always contact us if you need some assistance.